Hi everyone, in this video we'll take several examples about how to find the first derivative using the techniques of differentiation. So we'll start with part A, and in all of these parts you have to find dy by dx, or the first derivative. For part A, we have radical 2 multiplied by x plus 1 over radical 2. So dy by dx equals radical 2 multiplied by x, the derivative of the first term is radical 2, plus the derivative of 1 over radical 2, and as you know 1 over radical 2 is a constant, so the derivative is equal to 0, and radical 2 plus 0 equals to radical 2. For part B, we have a constant multiplied by a function. So when you want to find dy by dx, or y prime, you have to put the constant down firstly, then you have to find the derivative of the function, and x power 7 we have 7x power 6 plus 2x is 2, and the derivative of minus 9, derivative of a constant equal to 0, so minus 0, and you can multiply minus 1 over 3 by the terms inside the bracket, and you will get minus 7 over 3 x to the power 6 minus 2 over 3. In part C, we have bracket to the power 2. So firstly you have to expand this bracket using this formula: a plus b square equals a square plus 2ab plus b square. Now in our example, 3x square is a and 1 is b, so you have to simplify or expand the function given, then you can start to find the derivative of this function. So y equals the first term square, 3x square square, plus 2 times the first term times the second term, 2 multiplied by 3x square multiplied by 1 plus the second term square, 1 square. So y equals 3x square square equals 9x to the power 4, and here you have to multiply 2 by 3x square by 1, and you will get 6x square plus 1 square equals to 1. This is the expansion of our function. Now you can start to find the derivative of this function. So y prime equals 9 times 4, 36, x to the power 3, plus 6 times 2 equals to 12x, and 1 is a constant, and the derivative of a constant equal to 0. So this is the final answer of part C. In part D, you have also to simplify the function or modify the function, then you can start find the derivative of the function. So firstly we can write y as y equals x to the power e is Niperian number, which is 2.7 approximately, plus 1 over x to the power radical 10 as x to the power negative radical 10. We simplify the function, so we can start find the derivative of the function. So the derivative y prime equals, you have to put the exponent down, e x and subtract 1 from the exponent. Then also for the second term, you have to put the exponent down, and you will get minus radical 10 x to the power minus radical 10 minus 1. And this is the final answer. We cannot simplify more. And in part E, you have also to simplify the radical you have here. We have cube root. You have to write it as a number multiplied by x power something. So you have to modify the function firstly. So we can modify or simplify this function as y equals cube root of 8. Distribute the cube root up and down over cube root of x to the power 7. And this is equals to 2 over x to the power 7 over 3. You have to move x to the power 7 over 3 up, and you will get a negative exponent. So 2x to the power negative 7 over 3. This is the simplify of our function. Now you can start the derivation. So y prime or dy by dx equals, you have to find the derivative of this simplified function. So we have 2 multiply by, put the exponent down, you will get minus 7 over 3 multiply by x to the power minus 7 over 3 minus 1. And this is equals to 2 times negative 7, negative 14 over 3 x to the power minus 7 over 3 minus 1. Minus 1, you can rewrite it as 3 over 3. So minus 7 minus 3 equals negative 10 over 3. And we can simplify more by put x to the power negative 10 over 3 down, and you will get a positive exponent, and you can use this one to rewrite it in radical form. So we have minus 14 divided by 3 multiplied by cube root of x to the power 10. And this is the final answer of part E. Now on part F, we have y equals x squared plus 1 divided by 5. Divide by 5, you can rewrite it as multiply by 1 over 5. So we can simplify to use this formula. Constant, the derivative of constant multiplied by a function equal the constant multiplied by the derivative of the function. So we can simplify y as 1 over 5 multiplied by the function x squared plus 1. And now we can start the derivation. So y prime equals the constant 1 over 5 multiplied by the derivative of the function x squared plus 1, which is 2x, and the derivative of 1 equal to 0 because 1 is a constant. So the final answer is 2 over 5 multiplied by x. In part G, you have to divide each term by x to simplify firstly. So we can write it as x to the power 3 over 2 divided by x plus 2 divided by x. And as you know, when we divide, you have to subtract the exponents. So we have x to the power 3 over 2 divided by x to the power 1. So y equals x to the power 3 over 2 minus 1, which is 2 over 2. So 3 over 2 minus 2 over 2 equals 1 over 2 plus 2 over x. We can move x up and you will get 2x to the power negative 1. After this simplify, we can start to find the derivative of this function. So y prime equals, put 1 over 2 down, multiplied by x to the power 1 over 2 minus 1. And the same thing for the second term. We have plus 2, put the power or the exponent down, multiplied by negative 1, x to the power minus 1, which is negative 2. As you know, 1 over 2 minus 1 equals minus 1 over 2. So dy by dx, or y prime, as you like, equals 1 over 2x to the power half. Here we have 2 times negative 1, which is negative 2, and you can move x to the power negative 2 down to get positive exponent. So we have x to the power 2, and that's it. For more simplify, you can write x to the power half as square root of x. For the last part h, we have y equals ax cubed plus bx squared plus cx plus d, and a, b, c, and d are constants. So you can directly find the derivative because the function is in simplest form. So y prime equals, you have to put the exponent down for all terms. So we have 3a and subtract 1 from each exponent to the power 2 plus 2b x to the power 1, because 2 minus 1 equals to 1, and the derivative of cx equals c, and d is a constant, and the derivative of a constant equal to 0. So this is the final answer for part h. And that's it. Thank you.